What's up, everyone? Welcome to the Google Cloud Security Showcase, a special web series where we'll focus on security use cases that customers like you can solve with Google Cloud. My name is Ahmad Robinson, and I'm a cloud security architect at Google Cloud. In this video, we'll be looking at auditing and securing GKE clusters using the Center for Internet Security, or CIS GKE Benchmark. Whether you're starting fresh with a brand new cluster or you're working with several existing clusters, it's essential to protect your workloads from vulnerabilities and misconfigurations. The CIS GKE Benchmark provides a standardized set of security guidelines that can help you achieve this. I meet with many customers who always ask what is the most efficient way to evaluate and apply security best practices to their GKE clusters. Many of them, which may be you too, not judging, are used to doing this the manual way. This is where you research our documentation, you look at videos, you look at articles, you evaluate your current Kubernetes environment in your data center, and you come up with all of the necessary security settings and configurations that should be implemented in your GKE clusters. And you may even manually enforce them. The CIS GKE Benchmark aims to improve this process by providing you with security best practices that are specific to your GKE clusters. Most cloud security breaches are linked to misconfigurations or overly permissive access controls. The CIS GKE Benchmark includes over 80 recommended controls specific to Google Cloud and GKE, such as enabling and specifying subnets for your control plane authorized networks, ensuring private clusters with private endpoints are deployed, making sure VPC flow logs and intranode visibility are enabled, and much more. And we've recently introduced the CIS GKE Autopilot Benchmark, tailored specifically for GKE's Autopilot mode. In Autopilot, many node-level security configurations are handled automatically by Google, such as enabling shielded GKE nodes, which protect against rootkits and other tampering methods, and using container-optimized OS, which has a smaller attack surface and has restricted firewalls. This ultimately makes it easier to maintain a strong security posture without the operational overhead. Okay, so you got it. The CIS GKE Benchmark is the way to go, and you should read this every night before bed so you can apply the recommendations. That should be partially true, but as far as auditing and enforcing these standards in your GKE clusters, that's where Policy Controller comes in. Policy Controller is a key component in GKE Enterprise that helps enforce policies on cluster resources to ensure they are compliant with organizational standards and security practices. It operates as an admission controller, intercepting requests made to the Kubernetes API before they are persisted to the cluster, and is based on the open source Open Policy Agent Gatekeeper project, or OPA. This ensures that the policies are evaluated before any changes are made. Policy Controller integrates with various components like kubectl, config management, and API clients, ensuring that policies are enforced regardless of how cluster resources are being managed. At its core, Policy Controller works in two main stages. The first one is the rule definition, where admins define policies that specify how resources in the cluster should behave or should be configured. The second one is enforcement, where Policy Controller then enforces these policies by reviewing incoming requests to ensure they are compliant. This process is known as admission review. Policy Controller can operate in different modes: dry run, warn, and deny mode. Of course, we recommend you slowly move up to deny mode in a production environment. Be sure to leverage dry run and warn mode in a phased approach. So what about that CIS GKE benchmark? If you're familiar with OPA policies, you've already opened another tab and began looking up pre-created policies written in Rego so you can go ahead and enforce this in your cluster, right? Well, before you do that, one of the great features to Policy Controller is a policy bundle. Policy Controller comes with a host of pre-curated policy bundles that are part of an existing standard, such as the CIS GKE benchmark we've been talking about, NIST 800-53, PCI DSS 4.0, or just general best practices such as policy essentials or cost and reliability for running cost-efficient clusters. These bundles include relevant policies that can be applied in bulk to individual clusters or to a fleet in dry run, warn, or deny mode. And of course, you have the ability to write your own policies or apply individual pre-created policies as needed to your clusters or fleet. Finally, the most efficient manner to take advantage of the CIS GKE benchmark and Policy Controller is not to apply these manually to your cluster. Of course, you are welcome to do this if that's the model you operate in. But ideally, we like to approach this in an automated CI/CD and documented manner. So now our security operators and cloud admins can collaborate on policy bundles or individual policies that meet the organization's standards, and pushes these changes to a Git repository that is managed by config sync. Config sync can then reconcile these policy changes to your fleet, which may consist of GKE clusters deployed across a hybrid or multi-cloud environment. Config sync is beyond the scope of this video, but I have an alternative for you as well. We can also use Cloud Build, or in my example, we're going to use GitHub Actions as the infrastructure CI/CD component. What we are defining here in Terraform is that we want an existing cluster to install Policy Controller and apply the CIS GKE Benchmark in dry run mode. Once installed, our operators can view the policies and their violations in the console or via gcloud CLI. So let's show how we can make this happen. First, let's go into the Cloud Console where I can show you the cluster I've already deployed. We'll navigate over to GKE and look at our cluster, where you can see Supercluster 2 has been deployed. It is not part of a fleet at the moment, and if we go down to policy on the left-hand side, we can see that the policy controller has not been installed. We'll double check this by looking at the setting for the cluster itself. As I mentioned, this environment is automated and uses an infrastructure as code GitOps method. So to make our change, we'll head into Visual Studio and view the current Terraform module for Supercluster 2. What we'll want to add here are blocks that designate that this cluster is part of a fleet, and we'll have Policy Controller installed with the CIS GKE Benchmark applied in dry run mode. Once I have defined this block, I will push this to my repo where GitHub Actions will plan, test, and ultimately apply these changes to my environment. After about 15 minutes or so, we can see that the Policy Controller installation has successfully completed. Now let's take a look at my violations. Here we can filter based on the bundle, where I actually have 2 bundles applied, and we can even filter based on constraint, namespace, or resource kind, which admittedly isn't too much in my current environment. Let's take a look at one of the applied constraints, which requires that each namespace has a network policy defined. Here we can see the details on the policy with the description, recommended action, and the YAML of the constraint itself. I can also see the affected resources, which in this case would be the 2 namespaces that are part of this cluster. If needed, I could have exempted Policy Controller from applying this policy to my default namespace. Now we'll take a look at one more policy, which requires that each container have the security context set. Here we can see similar information, but notice how I can get all of the details in the YAML file itself, which enables me to modify this in the future if needed. Now we'll step away from that environment to look at another project where I have many more resources deployed. Here we have 12 GKE clusters spread across a multi-cloud environment. And within Policy Controller, we have applied all of our previous bundles. When looking at the violations, you can see how beneficial the filters are now that we have so many resources, including workloads deployed to this environment. And I will see similar information if I look into each policy violation. So overall, this is how you apply industry standard GKE security best practices to your GKE clusters using the CIS GKE Benchmark. Policy Controller simplifies this process in greenfield and brownfield environments. And you have a variety of ways of ensuring that this is automated, documented, and locked down. Be sure to take a look at GKE Enterprise as a whole to see how it can enhance your security posture. Thank you for watching. And if you found this demo helpful, be sure to like, subscribe, and stay tuned for more insights into Google Cloud security and best practices.